it that way. Okay. Recording has started, and we have 10 o'clock. You're good to go, sir.
All right. So first things first, welcome everybody. I'm Yahya, and this is a session I created a couple of years ago called SolidWorks Animations 0 to Hero. And that's actually the whole idea behind this session back when I created it a couple of years ago, which is I'm really passionate about animations, but most engineers think of animations as that cool thing that the guy who plays with the rendering should be interested in, not pretty much anyone else. And this session is not only to try and convince you otherwise, but at the same time show you another side of SolidWorks, what I would call the artistic side of SolidWorks. Okay, so before we start, massive shout out to James for getting this all set up. And by the way, this is my very first time presenting to a user group that's like not part of like a city or a country, so it's a new experience for me as well. Okay, this is a bit of a quick introduction about myself, in case anyone here doesn't know me. You've been using SolidWorks for like 9 years now. I started pretty young. I started like 14 years old, and that's actually what led to the whole thing that we're going to talk about today, which is that artistic or non-mechanical design use of SolidWorks. Because back in that day, for me, SolidWorks was a design tool, not specifically a mechanical design tool. I got introduced to it through my sister, which is also an engineer. I actually come from a family of engineers. So for me, it was like I'm just watching her, seeing what she can do and trying to mimic that. And at the same time, just figuring stuff out myself. But I really didn't have any engineering background to guide me, not back then at least. But yeah, that's pretty much what you should get from all of this. That's what's really important. I hope all of you guys know Herbie and Johnny. They're two user group leaders from the UK. I actually joined them on the podcast a while ago and got a bit more in depth about how I got to know about SolidWorks at that young age and how I started learning it on my own and stuff like that. So if you're interested in something like that, this is I think it was like an hour-long podcast where we started chatting about all things SolidWorks. Anyways, that's not what you're here for today. We're here for animation. So here's today's agenda. We're going to talk about motion studies. And that might actually sound a bit strange for those who read the title, SolidWorks Animations, because what's the difference? So that's the very first thing we're going to start about. What's the difference between motion studies and animations? Because personally, I used to get confused all the time between the two. And just a quick hint, motion studies is like the umbrella term, and animations is like a subsidiary of that. So there's actually other types of motion studies other than animation. So we're also going to take a quick look at some of those as well. And the main thing is we're not just going to take like a quick glimpse. We're actually going to take a bit of a deep dive into most of the techniques that you would use in most of the well-used types of motion studies. And at the very end, we're going to showcase how you get all of that out of the software and present it in what I would call a presentable way, a nice, good-looking, eye-catching way. Okay, so let's get started. So the first thing is motion studies. This was probably the first question that anyone should be introduced to, which is why should I even care? Why should I spend time and effort after I finish my design to create an animation or to do a motion study? Why is that useful in any way or shape or form? And for me, there are three things that it comes down to. The first thing is it's eye-catching. You can't ignore it. You're just like scrolling on Facebook or TikTok or even LinkedIn, and you just find an animation and you just have to stop and look at it. It's not something that you just look at and just scroll past. It's simply scroll stopping. Okay, and it can be as simple as this laser cut lantern that I designed a couple of years ago. It was a very simple design, and I created it, posted it on GrabCAD. It got like 200 views or downloads. That was pretty much it. And then a couple of years later, I just opened SolidWorks, got that part, looked at the feature tree, said to myself, how the heck did I even design something that bad? I was still young, but the main thing is I recreated some of the parts and then I animated it. And I posted the animation. I didn't even post the CAD files. I didn't post all the time and effort that I spent creating something like this, making sure every tolerance is perfect or anything. I just posted the animation. And guess what? That animation got thousands, if not tens of thousands of views. And people started reaching out on there saying, that's really cool animation. How can I do something like that? I never got any of that attention to the main CAD model, but I got all of it to the way I presented it. Remember, it's pretty much the same model. I didn't change much. Visually, it's pretty much the same. But the only thing that differed is the way I presented it. And that's going to get us to the second point, which is some models are just not justifiable to be shown from one still view. You know, take this image, for example. Can anyone tell us in the chat or open your mic what that is? Personally, if you ask me, I would say that's a very colorful couple of bars, and that's pretty much it. I have no idea what it's used to, what it's used for, what the goal is. But the moment I see it in motion, I understand. Oh, okay, so we've got these three rods, they're like rotating, and that's translated into like this reciprocating linear motion. So I wouldn't really fully understand the goal behind that design until I actually see it in motion. And that's the case for many mechanisms out there. They're just not fully represented in a still image or in just a CAD model that's still in front of you as a screenshot. And now that brings us to the third thing, which is, let's say, for example, this model. Does it say Yahya or does it say Khedr? Or does it say both? Because sometimes showing your model from a single view, from a single angle, is also not enough, especially when it comes to intricate details or parts that are hidden inside of other parts, stuff like that. So let's say, for example, we've got a box and I put inside of that box one of my best designs ever, but it's in that box. You can't see it unless I actually open the box and show you what's inside of it. So that's the case. Sometimes we actually need to balance all three of them. We need a good way to represent our models. We also need to show it while it's in motion to showcase the true value of that model, the true functionality of it. And the third thing is, usually it's not enough to show it from one still view. You usually need to show it from multiple views. Technically, I can just take a couple of screenshots from multiple views and show that to you. But that brings us back to the first point. Is that more eye-catching than something like this? So that's pretty much what I would consider why I would use motion studies. And remember, I mentioned that motion studies for me were something that I used back when I started using SolidWorks at 14 years old. So there's a fourth reason, which is to have fun. And by the way, you see this video right in front of you? This is me scrolling on Facebook, seeing something and just stopping, going to check it out. And by the way, this whole video that you just saw was 100% created inside of SolidWorks. Don't believe me? Okay, check this side by side. So what I basically did is I did like a rectangle, an extrusion, put that screenshot as a decal, and just animated the camera moving around, and that's pretty much it. I'm definitely sure that the product managers and engineers and software programmers at the SolidWorks didn't take this use case into consideration while creating animations and motion studies. But imagine if it can do something as silly as this, it could definitely do something more robust and more worth your time. Okay, so with that out of the way, let's get into the different types of motion studies. So I'm going to talk about only two today, but remember that there's actually a third. So motion studies, they come in three flavors: animation, basic motion, and the third one is called motion analysis, which we're not going to cover today because for starters, it's a big thing of its own. And the other thing is it actually crosses the boundary between artistic animation and starts getting a bit into validation and simulation and that kind of stuff. And the other thing is as well, it's not actually available in every release of SolidWorks, unlike these two. So whether you're using a standard edition, a professional edition, premium edition, if at home you've got like a maker's version, if your son has like the student edition, every single edition and every single release of SolidWorks comes with these two: animation, basic, motion. But for motion analysis, it's only with SolidWorks Premium. So it's not going to be for pretty much everyone, which is against the theme of this session. Okay, so now let's get back to these two. What's the difference between these two. And I'm going to talk about the difference in terms of what we actually care for, because at the end of the day, it comes down to which am I going to choose. So what am I going to choose based on? So when it comes to animation, it's based on one of two things. The first thing is called a key point. And we're going to get a bit more in depth of what a key point is. But we can think of it as like a still screenshot in time. You just like capture the state of your model or your assembly or your part at a certain point in time, do some changes, and then capture the state of it after the changes. And you tell SolidWorks, hey, please move from this first state to the second state. That's pretty much it. And the only control that you have is that state, the first one, and that state, the last one. Anything in between, if you want to control it, you have to add another state. So that's what you actually design. You create those key points and you tell SolidWorks, hey, please do some transitioning between every key point and the other one. Okay. And transitioning is obviously the better term, but in SolidWorks, we call them interpolation. No idea why, but that's the term that we use. Okay. So that's the first type. Once again, we set everything up and then we do some changes and we tell SolidWorks, like, animate or interpolate or transition from the first state to the second. The other type is based on motors. So in this case, you add a virtual motor. You don't actually have to have the motor model. You just add a virtual motor. You say, okay, here are the parameters, the speed, the direction, and so on. And you set what it's attached to. So it might be attached to this wheel, this linkage, this bar, whatever it is. And then based on those parameters, you just hit calculate and SolidWorks would run the animation for you. Okay, so that's when it comes to animation. Pretty simple. When it comes to basic motion, well, it's a bit more realistic. So it's physics-based. You've got things that we see in everyday life, things like gravity, things like contact, because we've all been at that point where we've got the cool design ready and everything is perfect, and then you do an interference detection and you find that you've got small interferences between every model and the other. And SolidWorks doesn't mind. If two things occupy the same space in 3D, SolidWorks won't say no. But in physics, we know that that's impossible. So that's when it comes to contacts. You can actually specify, hey, if these two things come into contact, don't go through each other. You have to actually collide and repel and stuff like that. So that's something that you'd only find in basic motion. And there's also, since we're talking about physics-based things, yeah, we do get a bit near simulating stuff, but it's not like motion analysis. It's way simpler, way easier, and way less computationally intensive. So it would definitely run way quicker than if you do the same setup, but as a motion analysis. Okay. So what should we get from this slide is the following. If we already have all the inputs and we already have all of the outputs, we know this beginning state and the end state and any state in between. We already know every single state of the model. In that case, we would go with animations because we would save those states as key points and just tell SolidWorks to move from one state to the other. But we've already given it everything. On the other hand, if you want to like set up the environment, say, okay, this and this have contact, this and this have contact, set the gravity downwards, this is the acceleration, this is that, hit calculate and just wait for SolidWorks to amaze you with the setup that you created. In that case, you only provide the inputs, but you're waiting for SolidWorks to calculate and then show you the outputs. And in that case, you would go for basic motion. Okay, this is pretty much the longest slide in terms of text that we were going to go through today. Everything else is going to be inside of SolidWorks, I swear. So let's get started with animation. But before that, we mentioned key points. So here's like a visual way of representing what key points or states would look like. So imagine we want to move all of these blocks from the left side to the right side. So this is the first key point, and this is the last key point. First one, last one. And that's pretty much it. All I want to do now is to tell SolidWorks to move from the first one to the last one. Now, there's a small thing that I mentioned that wasn't 100% true. I mentioned that we don't have any control over how SolidWorks will move from one key point to the other. That's by default. By default, it just does it. But if you want to, you can actually specify the speed of which it moves from one key point to the other, or as I should say, the acceleration, because we've got a couple of states. So there's linear, no acceleration, just time, the distance divided by the time, that's constant velocity, and that's pretty much it. We've got things like ease in. where it starts a bit slower and then it speeds up at the end, or something the opposite, ease out. It starts quicker and then slows down. And they've got something which I prefer, which is ease in and ease out. It does like this S-shaped curve when you plot the velocity and the distance and time, where it speeds up at the beginning, slows down in the middle, and then speeds up at the end. It takes it like in a smooth way. And there's the one that I never use, which is snap. It just remains where it is for the whole duration, and the very last moment, it just snaps into place. If for some reason you need it to do something like that. So that's pretty much the whole control that you have over the two key points. But remember, the start position and the end position is the same. That didn't change. The only thing that changes is how fast it went from that position to the other. Just that. Okay. So with that out of the way, let's leave it, do it one more time because it looks cool. And then we're going to go straight into animations. Okay. So I don't see any questions in the chat so far, so that's cool. Let's get into animation techniques. And I divide these techniques. This is not any official like table or anything. I just created this based on what I've used SolidWorks for. So we've got a couple of different techniques here. We're going to take it like from the very basic thing, which is basic dragging. You know, when you start dragging things by the cursor. So let's see how that would look like inside of SolidWorks. So let me open this model, and while I open it, I'm not sure if any of you have seen this animation before. Let me show it to you guys real quick. It was a cool animation that I saw, not as an animation, of course. So this is what we're trying to recreate right now. This trick where you've got a piece of chocolate and you start slicing it in certain ways, then you shuffle it in a certain way, and somehow you end up with an extra piece of chocolate, right? So yeah, it was pretty infamous back when I was young, and I had a couple of friends actually do it in real life in front of me, and I was always amazed about how cool it was. That one day I asked myself, you know what, let's actually recreate it inside of SolidWorks. So that's what we're going to try and do right now. Okay. So here's the model. I've got the assembly ready. Every component is split just as I want it to be, and the first thing to create an animation or a motion study in general is to go down here to the motion study toolbar. It's right now collapsed, so here it is. And this is an existing one. If I want to create a new one, I can just go ahead and create a new motion study. Okay, and now I've got a blank one, and let's just identify what we have right in front of us right now. So we've got a couple of things. So first things first, this thing here on the left, this is like a cropped down version of the feature manager tree that we're used to. So it only shows the things that you would control or use in an animation. So for example, if I look, I've got like the camera views, I've got the lights and stuff. Okay. When it comes to the models, I don't have any feature tree. I only have the things that I would need inside of an animation, as I said. So like moving it, exploding it, changing its appearance, controlling its mates, and that's pretty much it. That's the only things that we have in this cropped down version of the feature tree. Okay, all of that part here on the right is the timeline. This is what tells you, okay, at this point, do this, at that point, do that, all divided in terms of seconds. You can obviously like zoom in and zoom out. Okay, and you've got some tools over here at the top that we're going to go through while we go as we move along. Okay, so now let's think of a simple animation. Once again, we're going to start in the simplest way possible, which is like simple basic dragging with the cursor, nothing fancy. Okay, so what I want to do right now is I want to drag this piece over here, which I called thin long for some reason. Yeah, so I want to drag this piece all the way down. Okay, this is the first step. So all I have to do is just stop at the like 2-second mark, and you see this orange bar over here. This is called the time bar, which tells you where you're standing right now. Because remember, any changes that I would do would be saved automatically as a key point at the point where I'm at. So in this case, I'm at the 2-second mark. So any changes would be saved at that 2-second mark. If I don't do that, if I leave it at the 0-second mark, then in that case, the very start of the animation would be the changes that I would do, and that's a bit hard to fix. So it's a good thing to make sure that you first set up the time that you're going to change first. Okay, so right now we're at the 2-second mark. All I have to do, once again, basic dragging, just drag this component all the way down. I still haven't released my cursor yet. The moment I release it, now you see this. This is the key point. It has this rhombus shape. And this bar over here, this green bar, is called a change bar. Forget about the naming and stuff. What it indicates is that this key point is different than that key point. So in that case, SolidWorks is actually going to do some interpolation between the first one and the second one. And it's really important for a reason we're going to see in a moment. But remember, that's not the only change that we want to do. We also want to go over here at the 4-second mark and then move this sideways from the left to the right. So I'm also going to drag it and move it all the way over here. And once again, I've got another key point, as you can see over here, just added automatically for me. Okay, now, what else do I want to do? I want to move this big block, what I call this thick, long, this big block. I want to move it all the way to the right now. Okay, so I'm also going to stop at the 4-second mark and then drag this one all the way over here to the right, or the left in this case. And now I also have this new one, this new key point. But notice something. Where does this start? This movement or this interpolation, where does it start? It actually starts all the way over here at the 0-second mark. So if I think of it correctly, if I'm over here, while this thin part is still going downwards, this thick part is actually going to start moving to the side. And in that case, I'm going to have some interference. So what I wanted to do is actually to pause for a second until this first part is cleared all the way down out of the way, and then it should start to move to the side. And I know that that part is going to finish at the 2-second mark. So what I want to do is just make this not start from the 0-second mark, but actually from this 2-second. And that's as simple as just dragging this from here and releasing it at the 2-second. And in this case, this is the point where you mentioned, because here we've got a key point and here we've got a key point. But let me zoom in a bit. There is no change bar between them. But that indicates that these two key points are the exact same. And in that case, there is no need for SolidWorks to do any transition between them because they're the same. So that's really important because this is a visual indication to tell me, hey, here, there's nothing going to change, but down here, there is something going to change. Okay, same over here. This is not going to change until it comes to this 2-second mark, all the way to the 4-second. Okay, so this is like the very simplest way of managing the key points in the timeline. Let's stop for a second and just hit play and see how it goes. So this goes all the way down, and then this goes all to the side, and just like that. Okay, let's do a calculate this time. Taking a bit slower, but it's doing the exact same thing in a better way. Did anyone notice a difference between what we did when you just hit play and when we hit calculate? This is really important. Let me check the chat over here.
When you hit play, the thick piece did not move. It snapped instead of moving slowly. Yeah, so this is a really important thing because this actually troubled me a lot when I started using animations. And the whole thing comes down to the memory of SolidWorks. SolidWorks has a memory that I calculated this animation once. If you do any change, you have to remind me to recalculate it. If I check and I find that I calculated it previously, I'm not going to do it again, even if you did any changes. It's not the best workflow ever, but this is the way it goes. So for example, right now, you see this or like light yellow highlight over here from the 0-second mark to the 4-second mark. That indicates that this part was actually calculated by SolidWorks. Now, if I come back again and do any sort of changes in this area, in this from 0 to 4-second mark, so let's say, for example, I box select these and then change them all the way over here. Okay, I did a change. I'm not going to hit calculate. I'm just going to hit play. So what it's going to do is going to replay the last calculated animation that I had. Okay, so that's the thing. That's the difference between play and calculate. When I hit calculate, it's actually going to go back again and make sure that, okay, it's going to do it really quick and then going to do like from the half a second or something all the way to the 4-second mark. That's the new change that you did. So this is really important. If you did a change and you can't see it, it's probably because you forgot to hit calculate. Okay. On the other hand, you see this gray area over here? This has a gray highlight, and that indicates that it has not been calculated yet. Okay. And that can be as simple as, let's say, you see this very top key point? This is like the whole timeline of the animation.
Right now, the animation is 6 seconds long, but this part from 4 to 6 is not yet calculated. In this case, and only this case, whether I hit play or calculate, it's going to do the same thing because it has never calculated it before. So it's going to calculate it for the first time. So now when I hit play, you see it's going to go, and as it goes, it's going to turn that gray highlight into yellow. It's going to calculate it as it goes. Okay, so this is like the simple difference between both. Calculate, that's the perfect way to go, but it's a bit more time consuming because it's calculating it in the background. But once you calculate it, you can just hit play, and that's pretty much it. Okay, so we've got pretty much half of the way there. All that's left to do is just to bring this part all the way down here. So I'm going to make sure I'm here at the 6 second mark, drag this component all the way down, maybe somewhere over here. Okay, and yeah, I've got my key point in place. The last thing to do is just to hide this component over here, which I've called delete me. Okay, so I want it to be hidden from the 2 second mark to the 4 second mark, where it's actually out of view. Okay, because I thought that would make it a bit more interesting. So at the 4 second mark, I'm going to come over here to this delete me and just going to do hide. Okay, and now I've got this magenta or purple, maybe pink, I don't know, this new color. This is the one that's used for appearances. Okay, so in that case, all I have to do is just drag it from the 2 second mark to the 4 second mark and make sure that that change only happens from 2 to 4, where it's out of view. And now I can hit calculate. You know what, let me just collapse this to make it a bit full screen. I can hit calculate. It's going to start from the very beginning. So this goes all the way down, and this is going to move to the left while this moves to the right. There's a component being hidden out of view, and then this comes back again, and I've got the animation ready. Okay, so it looks cool and everything, but when I give it a bit more deeper inspection, I notice something funny happening over here. There's these weird interferences, because remember, what I did was move everything with the cursor, with my hand, and I'm definitely not, I don't have that steady of a hand to make sure that everything is aligning perfectly from the first time. So although I took like maybe like 7 minutes to do this as well as explain it, which is not that long, but at the same time, it's not really up to the standards that I've put to myself. Cool, but there's better. Okay, so this is what you can get from a basic dragging scenario. Everything is done just like that, no numeric control, as I should say. It would get you pretty much most of the way, but if you want it to be pristine, you want everything to align perfectly, that should take us to the next way of creating animations, which is in this case using mates. Okay, so we're going to recreate the exact same animation, but this time we're going to use mates. So I can just right click over here on this motion study, create a new motion study. Let's expand this. Everything is blank slate. And now let's start once again. So what about mates that we're going to use here? Remember, I use the term numeric control because the best way to control something like this is through a value. Let's say you've got like a distance mate or a limit distance mate, or maybe like an angle mate or limit angle mate, any mate that provides a value for you to change. So for example, a coincident mate, that can't be controlled on its own. You have to add something else to it that could be controlled. So for example, I've got a bunch of mates over here. Forget about those coincident ones. I've got these limit distance ones. Let me just expand this a bit. So I've got this limit distance for the vertical thin part, and that would move it up and down, okay, vertically. So I'm going to go over here at the 2 second mark, and then I'm going to go to this limit distance mate. If I expand it, I find this value or this property of it called distance. I can double click on it or change it. And in this case, I just get the modify dialog box just as usual, and I can enter 92.5, which I know is the value that I need. And just like that, I now have the new key point added, as you can see over here. I've also got the change bar, everything's perfect. If I hit calculate, notice that it's not calculated yet. So even if I hit play, that's fine. But as you can see, it now goes downwards as I want it to do. So it's doing that through the mate. I'm controlling it by the mate. Okay. Same thing can be done from the 2 second mark to the 4 second mark to move this part horizontally. So I also have this spot, this mate called limit distance horizontal thin. I'm actually really fond of my naming scheme. So I'm going to do the exact same thing. So I'm going to go with 40. And now I've got the precise distance that I want it to be moved to. And I also have the same thing, a change bar going all the way from 0 to 2, to 4, sorry. In this case, I can do the same thing, just drag it from 0 to 2 to make sure that it only starts moving when it goes from 2 to 4. Because remember, if I do this, it's going to try and do like a diagonal motion through the model like that. You know what? Let's see actually. So calculate, you see that diagonal motion? I don't want them to happen simultaneously. I can if I want to, but I've got full control. So I want it to happen one after the other. Okay, just like a waterfall or something. And at the same time, I want this big, thick part to move all the way to the left. So anticipating what I just did over here, where I had to add it and then move it, I can actually do something really cool. So I'm going to control it with this one, the limit distance, as you guessed it, horizontal thick. I can start by dragging this all the way to the 2-second mark. You notice there's no changing in the change bar, nothing happening at all. It's pretty much the same thing, but I've just marked the reference as the 2-second mark instead of the 0-second mark. And now when I go to the 4-second mark and do any sort of change, so in this case, I want to move it like 10 millimeters, it's only going to extend that change bar to the previous different key point, which is in this case at the 2-second mark. So anticipating the change that I want to do, I can do it in this way. Okay, and I've got pretty much the same thing. I can also come back and hide this delete me. I would also have to move this change bar over here. And then at the 6-second mark, and this is where it's really cool, all I have to do now is just modify that mate. So here's the mate that I wanted, the vertical one. Yes, this limit distance. Same thing here. When I change it over here at the 6-second mark, it's actually going to try and do it all the way to the 2-second mark. So I can just also copy this Control C from at the 2-second mark, come over here at the 4-second mark, Control V, and paste it. I can also copy and paste these key points, as you can see. And then when I do any change from the 6-second mark, it's as if I'm adding this pause to the animation from 2 to 4. So now all I have to do is just go over here to this distance and change it to the minimum, which is 32 point whatever. But in this case, since I have a numeric value that I could use, I have precise control over where it should be. Okay. And now if I hit calculate, this goes down, this goes to the left, this goes to the right, and then this goes all the way up. Oh, I actually did it a bit too much, which is good because I should know the value of this. Let me just modify it. And this is actually a really cool thing because now that I've got a value, I can just change this value as a number. Let's call it, actually can't remember how it was supposed to be. I think it was like 45, maybe. Let's rebuild. But the cool thing is I've got a numeric value that I could use. So in this case, I can simply change it until it actually looks cool. And it's probably somewhere between. And you know what? Anyways, I'm just going to do this one last time. 43.75. No idea why. It's right. Okay, cool. It's actually 43.75. And as you can see over here, there was 0 interferences because I've got the exact. Obviously, the way to go is to use the measure tool or something, not just the other way. But if it works, then it works. And technically, we ended up with the exact same result. But the cool thing is, which we somehow actually managed to show, if for any reason we want to modify something or change it, we actually have a numeric value that we could just increment in small increments to make it work exactly as we want it to. Something like that would have to be through the mouse. And once again, if you guys have steady hands, I do not. So it's going to be definitely impossible for me to do something like this just by dragging components around. And just because I'm feeling lucky, let's go ahead and do one interference detection. And yep, no interferences. Okay, so with that out of the way, it's up to you to use whether just dragging components around or to spend the time. Because once again, I had to go into the assembly and add these mates specifically for the sake of the animation. If we're just talking about the chocolate bar, doesn't need these mates. But I added those specifically in those types, limit distance mates, because I know that I actually need to modify them later on in the animation, which is a term that I probably coined myself. We all heard about design intent. I would call this animation intent. Designing with the intent of the animation. How would I animate this in the future? Okay, so yeah, that's pretty much it when it comes to the mere basic ways of animating something. So we covered basic dragging, we covered mate. Now let's talk about camera movement. What we saw earlier was moving components around. Now let's talk about what if the components are going to be still or moving, it's up to you. But what we want to do right now is to change the way we look at the model, okay? So this is the model that I showed earlier in the slides. Okie dokie. And do you notice anything different in this model compared to the previous one? The previous one was an assembly. This one is a part. And yes, you can animate just a single part. Although you're going to be a bit limited in what you can do. So you definitely can't move it around, but you can move the way you look at it. You can also change the appearances, do all of that sort of things. But it's within reason, right? So anything that you can do in an animation, you can do it also with a part of an assembly or a part. Both of them are the same thing, other than moving components around, because that actually would need a reference to move it about. But anyways, we've got this model over here. It says Yahya from here, it says Khedr from here, which is my last name. And now what I want to do is to animate that movement from one position to the other. So I'm going to go over here, create a new motion study. And just like we saw earlier, all I have to do is just come over here from this view. So this is Yahya. Maybe zoom in a bit. Yeah, let me zoom in. Yeah, that looks cool. And then let's say go to this 2-second mark, change it to the other view and call it a day, right? Except that I don't see any camera key points or anything added. And that's actually by design. So the thing is, usually you don't have everything that you need in your animation previewed to you in that still frame that you're starting the animation with. You might need to select a face from back there, so you might need to rotate, maybe zoom in, zoom out, stuff like that. So you don't want SolidWorks animations to automatically capture all of these movements. Sometimes you would need it to, hey, just take a second, only save the view keys when I tell you to. Only view keys. Any other movement, that's probably going to be intentional. But when it comes to view manipulation, it's usually not going to always be for the animation. So that's why if I right-click the animation and orientation and camera view over here, I have this option called Disable View Key Creation. And it's on by default. It's disabled by default. So in that case, it's not going to create a new view key for me or a key for views unless I actually disable this one. Okay, so I'm just going to disable it, or like enable it in this case, because I disabled it, disable whatever. You understand what I mean. What I'm going to do now is do any sort of change. And now, as you can see, I've got this white key point, and that is saved. Okay, so let's start once again. As you can see, it just interpolated between the two views that I started from. So let's back up for a moment. I want it to start from this view. Okay, maybe zoom in a bit. And all of that is being saved at the start point. And then at the 2-second mark, okay, I wanted to do something a bit similar, but from the other way, from this view. Okay, maybe something like that. Okay, although I don't see any changes visually in these two key points, it saves all of that because it's automatically saving everything in the background. And now if I hit play, it's going to animate from that one to that one, which looks cool, but not cool enough. It's missing a couple of things. The first thing it's missing is, okay, it looks cool from Yahya to Khedr, but that's like a 2-second animation. That's not going to catch anyone's eye. Like the sweet point, the sweet point would be like what, 5, maybe 10 seconds. So I can drag this all the way to the 2-second mark and make it a very slow animation. Let me play it from the very start to go from Yahya to Khedr. It's going to be very slow, but by that time people have already scrolled by, and that's not really the way to go. So in that case, I can utilize another thing, which is in this bar over here. So let me zoom in once again. You see these are the playback modes. It's by default just going to be the normal mode, just play. When it finishes, just stop, and that's pretty much it. But you also have other modes. We've got the loop mode, which is when it finishes, we'll replay from the very beginning. Or reciprocate, which is go in reverse. So you go forwards, you go in reverse, you go forwards, till infinity. Okay, so I prefer loop because that means that you would see the exact same animation as I designed it over and over and over and over again, and that you won't even notice that you're seeing it again. But this also has an issue, which is, let's let's play this as it is and notice something. So it goes from Yahya to Khedr, and it snaps back to Yahya and goes to Khedr, right? So in this case, what I would need to do is actually copy my beginning and make sure that the end of my animation and the start of my animation are the exact same key point, so that it would follow the same loop. And in this case, when I hit play from the beginning, it goes from Yahya to Khedr, and then back again to Yahya, and then over to Khedr, and so on. Okay, so we're getting there, but there's still something funky about it. It's not easy on the eyes. And I think the reason is, now, you see that it goes from Yahya and it just bumps into Khedr, and then it goes back to Yahya and it bumps, and then it's not smooth animation. And remember, I've already set up pretty much all that I can. I put the key points, and I've got no control over anything else except the interpolation. Remember that term that I really despise? Why not call it transition? Anyways, so the way to get there is really intimidating. It's a right click, and then at the very end of the menu, you find the interpolation mode. It's as if SolidWorks is telling you, don't find me. But once again, when we change the interpolation mode from the default, which is linear, to ease in, ease out, which is what, as I said, my favorite, you notice these icons they have over there. Though these would show the distance versus time plot. So linear, as I said, that's like constant velocity, no acceleration whatsoever. Snap, no change until the very last moment. Ease in, start slow, and then be way faster at the end. Ease out, which is the opposite. You start quick and then you slow down at the end. And ease in and ease out. This one, it starts slow, speeds up in the middle, and then slows down at the end. It's like this, like a sine wave. It's really smooth. So that's what I would use in this case. So let me use that one, not just here, also in this key point. By the way, I can just box select both of them and just apply interpolation mode to both of them. That's also going to work. So now let's play from the beginning and see how it goes. You know what? Let me also collapse this, make it like full screen. And now you tell me, isn't this way smoother as an animation? It's actually way zoomed in. Let me get it back again. Okay. It's way smoother. It's the same animation. I didn't change anything. The only thing I changed is how it went from one key point to the other. Okay. So we're already getting there. We've improved a lot of things. But there's one thing that just itching it back over there, which is it's not realistic. It's still got cool animation and stuff, but when I look at it, I expect things to have perspective, and this has none. This is like the pure fun play, nothing realistic at all. And the last time I saw something not having perspective was inside of SolidWorks. Remember, we're trying to do something artistic, so we're trying to make this as realistic as possible. So imagine you saw an Altec truck down in the street, and the boom arm all over there was the same size as it would be while it's near you. That would be so freaking. So in that case, it would make sense for us to start adding perspective to something like this. Now, you could just go over here and add perspective, but how much control do you actually have over that? And this would lead us to the next point, which is what I would consider the pinnacle of SolidWorks animations. If you use this, you've already reached the best way you can create animation ever. You've got the best tools. And let me show it to you. So I'm going to go back again to the model view from the tab down here. So I'm just switching from the model to the motion study. And I'm going to go to this display manager, which we never use because, you know, adding these appearances really does slow down my models, but it's for a good cause. So bear with me. I'm going to go to the third one over here, scenes, lights, and cameras. That's what we're going to add. We're going to add a camera. And from what we're going to see together, cameras are basically SolidWorks handing to you all the controls, literally all the controls. So let's see what happened here. When I started a new camera, I got this split screen view. Okay, so over here on the left, I've got the model view. This is like if I go to trimetric or isometric, I've got my model, I've got the camera, stuff like that. And over here on the right, this is the camera view. This is what the camera is going to see. This is the output of the camera. Okay, so we have two things to consider here. We've got this red dot, which is the target point. When I move this, the camera is stationary, but where it's looking at is moving around. Okay, and then we've got this yellow point over here, and this is the camera position. So when I move this, I've got this cool effect where the camera is looking at the same point in space, but it's just looking at it from different angles. Okay, so I can be all the way over there, maybe looking from the top, from the bottom, stuff like that. Okay, so between both of those, I've got pretty much all the control I need. Plus, if I check this one, this option, show numeric controls, which you've probably guessed by now, I love numeric control. So now I can nudge every camera by like millimeters to the side or to the top, making them exactly where I wanted them to be through this numeric control. I can start by just doing it by hand, but then the fine tuning can be done with these numbers. Okay, so let's scroll down and see what else we have. We've got the control of the target point over here, the camera position. We're also going to get into that. If for any reason you want to rotate your camera, you can also do that. By the way, I've never used that ever. So you make use of that as you'd like. You've got here the perspective, which once again, I told you, SolidWorks is handing all the controls to us. So if you want to turn off the perspective, we can do that. No depth of field, nothing whatsoever. But if you want to add it, and this is the gem, you can actually modify what kind of perspective you're looking for. When I pick up my phone, I don't have like multiple cameras back here. I've got one for like telephoto lens, which is like for spying on my neighbors. Oh, sorry, which is for like grabbing like zoomed in shots. I've got the wide angle, which is like for group photos. A lot of people standing on stage or something. And I want to have everyone, so it's a very wide field of view. I've got all of these, but these here on my phone are separate cameras. Here, it's just as simple as just changing this drop-down menu to like a wide angle, and just like that. Remember, the camera position and the target position are the exact same. The only thing that changed is like the lens that we're looking at the model through. Okay, I can change it to like a telephoto, very zoomed in, or I can do like a custom thing. So I can say, okay, let's imagine an arbitrary lens where the angle is 1 degree. Yeah, for some reason. You see that teeny tiny window over there? That's the preview window. If you want something like that, you've got full control. Okay, now let's go back again to realism and use something like this. I can also change the aspect ratio, which is so cool because, believe me, the worst thing ever is seeing like a video being shared or an animation or motion study that looks cool, but it's like this very short and very wide animation. I'm pretty sure most of you can relate with what I'm seeing. I see it all the time on LinkedIn, and I know that it's the default of SolidWorks to just hide all the task pane and hide the command manager when it's saving animations, but it doesn't collapse the motion manager at the bottom, and it doesn't collapse the feature manager or the command manager at the top. So you end up with nothing on the sides, but things obscuring your view at the top. And SolidWorks just captures the whole scene. So it captures a very, very wide view. And I actually measured it at one point, and it ended up being the aspect ratio of about 32:9, which is wider than the world's widest monitor. So you've got no luck ever presenting something like that and not having like these ugly black bars on the top and bottom and sides of stuff like that. So it's really important to consider the aspect ratio. You've got things like 1:1, which is useful if I'm presenting to my grandparents, but it's also an option to go with something a bit more modern, like 16:9, which is pretty much the standard for all TVs, cameras, laptops, whatever. If you want it to be like to be cool, you can do something like this. 9:16, that's for TikTok, if that's something you're interested in. But once again, you've got 100% full control over the aspect ratio from the get-go. So I would go with 16:9 because I am a sensible human being, and I'm going to hit okay. One more thing. I still need to set the target position and the camera position. So fun fact, it doesn't have to 100% rely on these values. I can just select from here the origin, and now it's looking directly at the origin. Wherever the origin goes, the camera follows. And then when it comes to the camera position, you can do it in X, Y, and Z, Cartesian or spherical, which I actually prefer because this gives you the same 3 values that you would have in X, Y, and Z. But in this format, you've got the distance from the target. So literally the line, the length of the line. Let me try and select it or highlight it. You see this line from the yellow dot to the red dot. Okay, let me actually choose another color. See this line from the yellow dot to the red dot. The length of that line, you can actually specify how long that is. So that's really cool. And the other thing is the angle. So we're talking like to the side and to the top and the bottom, the longitude and the latitude. So in this case, I can say, maybe I don't want any elevation. Okay, so 0. So I'm looking at it straight ahead. And when it comes to the distance, maybe some, because I can see that it's very small. So maybe like 250 millimeters. Cool. Maybe leave it as that. And then the angle side by side, I can change that. So in this case, I know that I'm looking at from 45 degrees. So it's going to be negative 45 degrees from this side. Okay. So, you know what? I actually think if I gave it a bit of elevation, that would give it a bit of depth. So that might actually look cool. And so far, so good. But remember, since I've got the numeric control, I can say my nitpicky self tells me that the distance over here, or the empty space, is way smaller than the empty space all the way over here. This is way bigger. And I like everything to be centered in the scene. So in this case, I can deselect the target point and just nudge it very slightly to this side, and maybe nudge it a bit this side. Okay, that's a bit too much, maybe like this. And I'm just nudging it with these values, with these numeric values, until it looks exactly how I want it to look like. Okay, so with that being said, I'm going to hit OK. And now I have the camera. If I deselect or like collapse this feature manager design tree, I see down over here, it tells me you're inside of camera 2 view. Okay, same thing when you go like to the front view and it tells you over here, you're in the front view. So the same thing, you have it in the camera. Okay, let's get back again to the camera view. And now let's revisit our motion study. So what I want to do right now is obviously delete all of this thing. Yep, go all the way to the 0-second mark. And I can notice that it's still using the first view that I had from earlier. And I want it to change to the camera view. Okay, so you can get the camera view from over here. You've got the list of cameras from this cube. Since I use cameras a lot, I actually added the camera view to my heads-up view toolbar. So I can just hit this button, and obviously it's on my wrong screen. I can select my camera. I can go to camera 2, just like that. I'm now in camera 2. Or you can also do this. You can right-click on this one, and you can go over here to the camera view. So the first key point in the orientation and camera view, you can also select camera view. Okay, if you also go to the view orientation, you also have camera view 1 and 2 over here. So there are multiple ways to use cameras, but please use them because they make the end result way better. Okay, you're going to see it for yourself, and it's going to be nice and day. Okay, so right now I'm going to be using camera 2. So let's go to camera 2. Okay, and then all I have to do now is just come over here at the 2-second mark. If I expand this lights and cameras folder, I have camera 2 over here. I can right click and go to properties and watch this. All I have to do is just come over here, go to this negative 45 or negative whatever it was, and just change it to positive. And now I'm looking at the model from the other side. And once again, since I changed the center point, I'm not rotating actually around the middle of the model. So I might need some slight nudging to maybe nudge it a bit to this side. Maybe too much. Yeah, maybe something like that. And I'm going to hit OK. And now I've got the key point added over here. What I have to do left is to copy this, paste that at the end, box select both, change them to the cooler, better interpolation mode. And then when I hit play, now, even if I collapse this, it's not going to change anything because everything is saved inside of that camera view. Now it's smoother. It's more controllable by me. And it's precise. It looks cool. And it pretty much checks every single point on my checklist. Okay. If anyone wants to nitpick, please do. But I think that from what I gather right now, no one is nitpicking in the chat. So I assume everyone agrees with me that this is a better animation compared to what we had previously. And by the way, in case you haven't noticed, we've actually watched this animation go on and on like 5 or 6 times, but you don't actually realize it because it's just looping one after the other. So if you actually don't see this bar going over here, you wouldn't know if I'm called Yahya Khedr or if I'm called Khedr Yahya, right? Because it's just going on, and there is no point where you'd say, okay, it's starting here or it's stopping here. Everything is just like fluid motion, right? Okay, enough of this. Okay, so that sums up the second method of creating animations, or like controlling animations, as I should say. Okay, which is through cameras. We also saw how to do it without cameras, but as I hope everyone agrees with me right now, cameras are the way to go. Now let's talk about appearances. We mentioned that appearances can be controlled in both parts and assemblies, and the goal here is to showcase multiple versions of your models. So let's open this model real quick, and let's consider this scenario. I have, let's say, my phone, okay? Let me just open it real quick. Okay, so I've got my phone. It's in white and this lime color, and the same design is going to be in like red and green, blue and just like a screenshot. Okay, blue and red, black and white, whatever. But the model is the same. So all I want to do is to change the appearance. Now I can do that and do multiple animations and stuff. But what if I want to combine all of that in a single animation? You know, these cool animations where you see something like twisting in midair and then just suddenly changes its color. Well, you can actually do that inside of SolidWorks. So I've got this model. This was supposed to be like a 3D printed spool holder to get attached to, I think it was like a 2x4 or something. So anyways, it's got multiple components, and I want to showcase how the different color combinations for this model would work like. Now, one thing to note, this model has a bunch of fillets. And the first thing I would mention when it comes to fillets is to go over here, view, display, tangent edges, and make sure it's set to removed, because this is what you would have otherwise. Not bad, but it can be better. Okay, so all of these lines, if for any reason you want them, that's probably going to be throughout the design phase. But when it comes to animations, I even have a keyboard shortcut for it to just hide all of them, set them to remove. So once again, you go to view, display, tangent edges removed. And by the way, this is saved with the model. So after you finish, and if you close and open the model, it's going to open the same way you saved it. Just a heads up. Okay, so now, once again, let's go back again to our motion study. Let's create a motion study, just changing the appearances. I can change anything else based on what we've learned so far, where the components are, stuff like that. But what I'm going to do right now is just change the colors, okay? So at the 2-second mark, let's say, for example, I want this half to be transparent. Let's go with change transparency, okay? As you can see, I also have this magenta change bar. At the 4-second mark, I can do something like these attached pins, I can hide them. So let's just select them and set them to hide. And I can also make these like 1 by 1, or maybe like after this as I want. And then at the 6-second mark, let's change this blue one. Let's right click, change the appearance, and let's set it to something cool. What color is the logo of Altec? I think it's black, right?
No. Like,
I think it's like the text itself is black, right? Let's go with black. You know what? Let's, instead of going with plastic, let's go with a solid metal. Maybe something expensive like gold. And since this is SolidWorks, there is nothing stopping us from doing black gold, just because we can. Okay. So just like that, I also have this set up, and I'm just going to drag this key point from here to here. Now, one cool thing that I would like to do is to give the user some time to realize what just happened, what changed in front of him. So for that, after I do this, I want everything to go back to the original state. But first, I'm going to like pause for a second. So for that, all I'm going to do is just copy all of these and paste them over here at the 6-second mark. Nothing is going to change because they're pretty much the same. And then I'm going to copy the initial states of everything and paste that at, like, let's say the 8-second mark. Okay, so now it's going to pause for 2 seconds, and then, okay, you know what? The top one didn't pause. So actually, let's make it at the 10-second mark, as I mentioned. Let's give all of these some time to pause. And that just gives the user some time to notice the change that happens. So like that, nothing happens over here. I just copied all of these endpoints, paste them over here. And then from 8 to 10, it's going to go all the way back to the original state once again. If I hit calculate or play from the beginning, this top part is going to gradually fade. The green parts are going to, the red parts will gradually change or disappear. And then the blue part would gradually change from blue to black. You know what? Let's actually make this one extend all the way to the beginning to make it even more emphasized. So notice throughout the whole animation, the blue part is going to 1 by 1 change from blue to black according to the speed that we set. In this case, it's going to be linear interpolation. And then everything is going to go back again to the original state at the end. Okay. So same model, same everything, but all I'm changing is just the appearance or the colors of the model. Okay, so that's the second use of appearances when it comes to the animations and key points in general. Now let's talk about motors real quick. So when it comes to motors, we've got multiple types of motors inside of SolidWorks animations. So let's open this model. We've got the rotary motor, which is the generic motor, just spins round and round. And we've got the linear motor, which is like a piston or like a pneumatic motor or anything that just moves in the same direction. But it doesn't actually have to be any of those, because imagine you have a model like this. You have this spring that is attached to this piston, and this piston is attached to this pointer. And then when this piston goes downwards, the pointer would go upwards. And if I hit rebuild, this spring should expand. And then same thing. So when this moves, that moves. And regardless of how I model the spring or anything, the main thing here is the motion that I'm looking for is for this red piston to move up and down. Okay, I can do this with mates. I can do this by dragging, but let me show you a cool trick to show you why doing it with a motor would be actually the better choice. So I'm going to start a new motion study. I'm going to go over here to the motors, which is this button over here, to add a new motor, and then change it to linear motor. By the way, remember when I mentioned that sometimes you would actually need to reorient your model to just select things? This is one of those cases. I want to select the top face that's over here, so I actually have to rotate it and select it, and nothing is going to change over here because once again the default behavior is to disable view key creation. So the red arrow is pointing upwards. I'm just going to change that downwards. And here I would select what it's moving relative to. So in this case, it's relative to this container. And then when it comes to the motion itself, how would I define it? I can do it with constant speed. So I can see, okay, how long this distance is and how long it should take to travel that distance, and just divide it by itself. And that's a lot of math for me. So what other options we have? We've got this distance function, which tells you, okay, don't divide them, just enter the values, enter the distance, enter the start time and the end time, and it's going to do the rest, which is still a lot for me, because I would have to do it once for the down position and then do it again for the up position. So it has to go down and up. So I have to change it multiple times. Let's see what other options we have. We've got oscillation, which is exactly what we need in this case, because this is a spring. So same thing, I've got this distance. So I would just enter the distance over here. I think it was 31.6 millimeters. And then the frequency. So frequency is pretty much 1 over the time. So I can just enter 1 divided by, let's say I want this to do like a full go down and go up in 2 seconds. So I'm just going to enter 2. No math needed. Kinda. Just hit OK. And just like that, I've added the motor. You're going to notice that any motor that you add, it defaults to 5 seconds because that's the default duration of any animation. But you can just drag this all the way back to the 2-second mark and then hit calculate and watch the magic. Okay, so it's obviously going to show it a bit choppier than what it's going to end up being when you export the animation in real life. So that's something to take into consideration. But yeah, make sure that you have like the general view or the general movement correct, and the smooth motion, that would be the settings for exporting, not really what you would see in this case. Okay, so it's also taking a bit longer because on every single frame it's actually rebuilding this spring model. So on every single frame it has to figure out what it actually looks like. So with that feature is going to be rebuilt in the background for it to do. But anyways, right now it's going downwards and upwards. Let me slow it down a bit. So instead of doing it like 1x speed, let's do it like half the speed and play from the beginning. Okay, so it goes down a bit. The spring is expanding, the pointer is changing, and then it goes up. And it does it exactly in the distance that we specified, 31.6, and exactly in the time we specified, which is the overall 2 seconds. So 1 second to go down and 1 second to go up. Okay, so just like that, in one linear motor that I added over here, I managed to control all of this motion, going down, going up, rebuilding the spring. All of that was just using one motor. So that's one of the benefits. Now, the other cool thing is if I go with the other example I have over here, which is for the rotary motors, sometimes you just want to show something in abstract. It's not really like an end result that you would showcase or have in real life. It's just like an idea that you just want to present. So in this case, I've got this triple transmission mechanism thingy, and if I create a new motion study, you notice that it's not attached to anything. It's just floating in midair. Because that's what I wanted to do right now. It's just an idea that I'm trying to showcase to my boss or something. So I can go ahead and do a motor, leave it rotary motor as it is, select any one of these. Because I've got the right mate set up, if I rotate any one of these, the other two are going to follow. Here's the direction, so I can leave it as it is. And for what it should be moving relative to, since it's in midair, I can leave that blank. And then when it comes to the speed, I think I'm going to go with constant speed for now. But remember, this is in RPM. Now, I don't really think that you're going to create an animation that's minutes long. But yeah, how long, what should the value be? So I actually have a couple of things to do. So RPM, that's revolutions per minute. So if I want it to be in terms of seconds, that's going to be 60. So 60 seconds per minute. And then I'm just going to divide that by whatever value that I want it to be. So let's say, for example, I want it to be like 5 seconds long. I can just do this, and that would tell me how much RPM I would need. Let's say I want it to be 60 seconds long, for example. I'm talking about one rotation, so I'm just going to leave it at 1 RPM. If I wanted to do like one rotation in 1 second, so that's going to be 60 divided by 1, 60 RPM, and so on. So just 60 divided by the time that it would take to do one rotation in seconds, and that would just give you the value. So in this case, it's going to be fairly quick to rebuild. So let's go with 5 seconds, hit OK, and the motor, it's already at the 5-second mark, so that's cool. Hit calculate, and then as you can see right now, it should do it real quick. And notice something while it calculates. If you look at the feature tree, it's actually quite compact for an assembly of this size because I'm actually using sub-assemblies. So you can animate with sub-assemblies, but you have to remember that if the components inside of the sub-assembly are going to move as well, you have to set that sub-assembly to be flexible. They like by default, they're set to be rigid. So here's the smooth output animation after everything is calculated. Okay. So what I mentioned is if I go to the model view over here, let me just do a Control Q real quick and zoom in over here. So you see this icon. This is different from the icon we see over here. This is the icon of a rigid assembly or a sub-assembly, but this over here is the icon of a flexible sub-assembly. So if you just select this, here's the icon to make it rigid or convert it from rigid to flexible. Bunch of errors, that's fine. As someone used to call them ketchup and mustard. We can convert them back again to be flexible. And just like that, we have the components inside of the assembly or inside of the sub-assembly able to move while they're in the top level assembly. Okay, so yeah, that's pretty much it when it comes to motors. How are we doing on time?
What we said to 11 for him. Or 11.
I think we're up to 11:30, but let me check with James. James, are we doing on time? Are we doing time?
We're getting close to the end of what I wanted the presentation to be. But I mean, how much you got left, Yahya?
I've got the last thing ever, which is how to get things out of SolidWorks, just the exporting process. Okay.
Okay. Yeah.
So if you give me like 5 more minutes maximum.
Yeah, you're good.
That'll
Yeah,
be
go for it. Go for it. I'm
Okay.
still setting up there anyway. You're good.
Yeah, I can go on and on for days, man. This is really one of the closest things to my heart. I'm presented on many things, but not as much of animations. So when it comes to exporting, it's really cool to have everything set up inside of SolidWorks, but it's not worth anything unless you can actually get it out of SolidWorks and present it in a presentable way, in a good manner. So here are some things to consider. Now, I already know that Altec, you don't do like external references. Everything has to be broken or everything has to be contained in the same file. Just in case. This is for you, not for your Altec work. If you ever do something with external references or something with in-context references where the part is referencing the assembly or stuff like that, if you ever do something like that, make sure that if that causes the assembly to change the geometry of the model, like the spring we saw earlier, or these fallen ratchets that we can see down here, if that's the case, note that it's going to take considerably longer times to calculate because it's, as I said, rebuilding on every single frame. Okay. Now, back in 2023 and earlier, when we had PhotoView 360 RIP, even if we rendered with RIP, even if we rendered with PhotoView 360, which got discontinued in 2023, you can't actually render the changing of geometry. You can only render changing of geometry if the rendering solution is SolidWorks itself, not PhotoView 360, not SolidWorks Visualize. It has to be SolidWorks. So it's a downgrade in terms of quality, but in terms of the capabilities that you would get out of it, it's way higher. Okay. Now, here are some things to take into consideration. The first thing is animations. They don't always have to be saved as videos. They can also be saved as files, as images, as like series of images. Every single frame of the video can be exported like on its own as an image. And you might not think that that would have much value. And I had the same idea until I was actually creating a thumbnail for one of my animations, this one. Okay. And I wanted to get this like like frame from the middle of the animation. I just want to export that single one. And that's pretty much the only scenario where I ever used exporting as an image, but it ended up being useful. So the image you see over here, this is taking mid animation while these balls are dropping and stuff. This is when I took it. So to export it as a crisp image, not like I'm going to take a screenshot from the video or anything, I'm actually exporting it from SolidWorks. That can be done in case you wanted like a cool thumbnail or something like that. Okay, now back to other things to consider. These are the two things, resolution and FPS. Resolution is talking about how big the image is. We talked about aspect ratio earlier, which is the ratio between the width and the height. The resolution is, okay, how many pixels is that going to be? So 16 by 9 can literally be 16 pixels wide by 9 pixels high, or 160 pixels wide by 90 pixels wide, or 1,600 pixels wide by 900 pixels high, and so on. So the higher the resolution, that means that that value, the number of pixels is bigger, and in that case, the quality of the image, the details that you can save inside of every single frame is more, and in that case, you end up with a more clear image. It's not pixelated or anything. And usually with resolution, we go to some of the standards. We're talking about like HD, 1280 by 720. We've got full HD, 1920 by 1080. Some numbers, these are standards for monitors, for displays, for laptops. So we would usually go with those. And FPS, frames per second, how many images are saved in every single second of that video? And that would determine how smooth the output would be. Because even if I used interpolation modes, ease in and ease out, for every single change that I do inside of the animation, if I export the video with a low frame per second value, that would mean that it's going to be very choppy. It would be like, it's not going to be smooth, even though I designed it in the beginning with a smooth mindset or with smooth characteristics. So that's also something to take into consideration. The output value or video, what frames per second are we dealing with in there? And then this is the worst of all, video compression. Because the worst thing ever is to have your animation very cool, very clean. You see it on your laptop, it's perfect. When you send it to someone via like WhatsApp or you upload it to Facebook or whatever it is, it actually gets compressed, and then you see like artifacts and stuff like that. So there's a workaround around the video compression part we're going to talk about right now, but it's gonna be mainly about two things. We'll talk about the file size, which is the end result of any compression to reduce the file size, but also the export time, because if you add an extra process of compressing the video, that would mean that it would take more time to export. So let's take this, for example. You've got here the same animation, nothing else. In the motion study, it's the exact same motion study. I just exported it with different settings. So the one on the very left, this is the uncompressed AVI. No compression whatsoever. An AVI, that's the file format that I used. Okay, that used to be the default. It's actually still the default till this day, but we didn't used to have any other video file formats up until like 2020 or something. Okay, so that's with no compression whatsoever. The one in the middle, still AVI, but with 100% compression, fully compressed. And by the way, what you're seeing right now, that's not Microsoft Teams lagging or anything. That's artifacts in the video itself. And the one on the very right, that's the MP4. And I want you to take close attention between the MP4 and the uncompressed AVI. Try to find any differences between them if you can. if there are any in the first place. So that's what we're going to try and see right now. So if I go inside of SolidWorks once again, I'm going to open that that motion study, and once again, it's the same motion study. I'm not going to change anything about the motion study itself. All I'm going to change is when I go over here to this button over here, this save animation button, and I click it, what options do I have and how should I manipulate these? So obviously you've got the file name, stuff like that, the directory, save as, and this is the important part. Anything that says series of, so whether it's like series of bitmaps, series of JPEGs, PNGs, these are all going to be still frames. Every single frame is going to be exported as a separate image. And the other ones over here, these would be video file formats. We've got for AVI, FLV, MKV, and MP4. And now let's look about the other options. So we mentioned the aspect ratio. So here it is. The aspect ratio, it can be derived from the camera, or you can set one right here. So my camera has a 2:1 aspect ratio for some reason. I can change that and override it with like a 16:9, and you would notice in the background it actually changed. And the number of pixels in every one of those, since I now have an aspect ratio, I can say, okay, I want it to be like 1280. It's also automatically going to go to 720. That's HD. I can go with like 1920 by 1080. That's full HD. The higher the number, the better, of course. Now frames per second. I sat down with R&D of SolidWorks twice, like physically sat down with them to talk about this 7.5 value, because this is the worst thing ever. Okay, it would really get out the worst video that you can ever see. And I mean, you can go with 24. You can go with 30. You can even go with 60. Actually, a couple of weeks ago, I realized that the film industry in America uses a very strange 27.78 frames per second value. You can use that, but please don't use 7.5 because that's very, very low. And you're going to notice that in your exported videos. So the animation would play better inside of SolidWorks than it would play inside of your video player, which makes no sense. Okay. But from my experience, 30 sounds like the sweet spot. Unless you actually have a lot of motion happening very, very quickly, in that case, you would go with the 60 value. So I think the only cases that I encountered that was when I had like the image I showed you earlier, where I had these balls falling down and stuff like that. So to capture all of these quick differences, I had to go with 60 frames per second. But other than that, 30, sweet spot, not big file sizes, nothing. It's perfect. Now, if you want, you don't have to export actually the whole animation. You can just export a single frame, as I mentioned earlier, or like a time range from like 1 second to 2 seconds. And that would be cool. So right now, if I go with AVI, let's just set the directory to my desktop, which is, there it is. Okay, I'm going to save it as an AVI. When I hit save, it doesn't actually save. It first tells me about the image compression. What compression engine would you like to use? There are many, or you can use the last option. No compression whatsoever, okay? So I can go with any of these. Let's go with like Microsoft One, which is probably going to be the default for most of you. And when I hit OK, it starts by going through the video, saving it, and so on. And now let's stop this and do it once again. The only difference this time is going to be, instead of AVI, I'm going to go with MP4. Once again, I'm going to hit save. It doesn't ask me for anything. It knows better. It's going to go straight ahead and start saving. Now, the cool thing is, even when I hit stop, you see these couple of like less than a second they exported. Those actually were exported correctly and are viewable. So I can go now and watch them, and they would work perfectly with no issue whatsoever. So that's actually a really cool thing to know. Let me show it real quick. So here's the animation that we just exported. Okay, like 0.6 seconds of animation, but you can just export it like that. So don't worry if you like hit stop by mistake or anything. What you exported is already going to be salvageable. It's usable. But now that we've seen the process, let's get back again to the outputs. Okay, the comparison. So the one on the left, let's take it left to right. Okay, uncompressed AVI 4-second animation, that was 292 megabytes. We're talking like more than a quarter of a gigabyte. 292 megabytes. Okay, but the quality speaks for itself. It was very high quality. The one in the middle, the fully compressed AVI, 100% compression, artifacts everywhere, colors not looking good at all. but look at the size. It's 1.5 megabytes. So that's a massive difference. But look at the MP4. Same 4 seconds, same animation, same everything. We're talking about 23 kilobytes, not megabytes, kilobytes. We're on a totally different unit scale now. Remember, the difference between a kilobyte and a megabyte is 1,000 times. So imagine the difference between the 23 kilobytes and the 290 megabytes. And personally, to my eyes, I couldn't find any difference between them visually or from a good-looking animation perspective. But the file size, it's night and day. So when it comes to me, ever since MP4 was introduced, as I said, I think it was 2020, and I'm pretty sure you at Altec, you use like more recent versions than that, right? You're probably at 2023, 2024 now.
2024. Yeah.
Okay, so we definitely have MP4 in your list of options. So please, I know that the default is AVI. It's tempting to just hit save, but we're not installing a software with just next, and save. Please take some time, set the FPS, set the resolution, aspect ratio, and set it to MP4. Unless for any niche reason you need to have control over the compression ratio. Other than that, MP4 just balances the file size and the quality. Okay, I think we went a bit over time, so that's pretty much it for today. Thanks to all of you guys for sticking for all this hour and 20 minutes. And I'm still around for any questions if you guys have any. And just a quick note, if for any reason you have further questions in the future, or if we couldn't get into your question for today, this is my LinkedIn. I'm also going to put it in the chat for those joining us virtually. I've got an open profile. Feel free to reach out with a message. Just if it's a question about animation, it doesn't even have to be a question. Just if you created an animation from this session, I would love to see it. Just post it on LinkedIn, tag me, tag James. I would love to see all of these. Okay. So with that out of the way, I'm open to any questions.
I don't think there's any questions in this room.
You know, I heard that if you don't have any questions, that means one of two things. Either you did a very great job that everyone understands everything perfectly, or you did a very bad job that nobody knows where even to start. So I hope it's the first one.
I can say for sure that you did a great job, Yahya. We do have one question in the chat. Troy says, going back to the lever and spring.
Okay.
That wasn't necessarily a question. I think he may have more to say. Feel free to come off mute there, Troy, if you want to just ask the question yourself.
Okay, can you hear me?
Yep, loud and clear.
Okay, so when you go back and look at the lever and spring, and you were changing the speed of how fast that it moves, is the type of spring configured as far as how fast that movement is going to be able to move?
No, so this is 100% a cosmetic thing. So
Okay.
this spring, I didn't define the material, I didn't define anything for SolidWorks to understand how fast it should go. This is 100% defined by the motor itself. If I want to, I can derive it from the spring, and for that, it's going to get a bit out of the realm of animation and a bit into the realm of basic motion and motion studies, where not only could you add motors, but you can actually add gravity, contact, and guess what? Springs. So you can define a spring and say, okay, this is the coefficient of elasticity. This is the rigidity of this spring. These are the parameters of a spring, and I would like you to show me the effect of like applying a force from this direction of this value and so on. So you can definitely use it for that kind of stuff. So you do have springs that would work with real engineering parameters, but the theme of this session was not really that engineering. It was more of the artistic side of it. But yeah, it's definitely doable.
Okay, thank you.
No problem.
Well, cool. I don't think we have any questions
we've got
here,
it all covered for now, yeah.
and I don't see anybody else in the chat. So we will let you get to the rest of your evening, Yahya. I know it's 7:30 there now.
It's only 7:30.
I appreciate you very much for taking the time during this presentation. I'm sure everybody can agree with me that you definitely did a great job, and our lack of questions is because of that.
Absolutely.
Well, cool. I appreciate you. You have a good evening, and we'll me and you'll talk later for sure.
Sure thing. Okay.
Yeah.
Thanks, guys, for sticking it to the
Thank you
end.
so much.
And yeah, see you soon. Bye-bye.
Bye.